One invisible rule controls everything in the universe. It shapes every star, every atom, every signal that moves through space. And it quietly makes one dream almost impossible, crossing an entire galaxy faster than light. Light is the fastest thing that exists. Nothing we know can outrun it. Not matter, not energy, not even information. And yet even light is slow when compared to the true scale of the universe. To cross our own galaxy, light needs more than 100,000 years. That is not a mistake. That is the fastest possible journey across something we call home. This raises a question that feels simple but hides something much deeper. Why does this limit exist at all? Why does the universe place a strict boundary on speed? Why can nothing go beyond it? Science fiction often gives easy answers. Spaceships jump across space in seconds. Entire galaxies are crossed in moments. It feels natural, it feels possible, but reality is far more strict. The universe does not bend easily. It follows rules that are deeply woven into its structure. And here is the part that most people never realize. This is not just a problem of engines or fuel or technology. Even with perfect machines, perfect energy, and perfect design, the barrier remains. It is not a wall built by engineers. It is a rule written into space and time itself. At very high speeds, strange things begin to happen. Time starts to slow down, length starts to shrink, mass begins to behave in ways that defy everyday experience. These are not science fiction ideas. These are measured effects, proven, tested, real. The faster something moves, the harder it becomes to push it even faster. Each tiny increase in speed demands more energy than the last. Near the speed of light, the required energy rises so sharply that it approaches infinity. That means there is a point where moving faster is not just difficult, it becomes impossible in every sense. There is another hidden layer to this mystery. Speed is not just about motion, it is connected to time itself. As something moves faster, time for that object slows down compared to everything else. Near the speed of light, time nearly stops. For the traveler, a long journey could feel short, but for the rest of the universe, time continues normally. This creates a strange divide, one reality for the traveler, another for everyone else. The faster one tries to go, the more this gap grows. It is as if the universe is reshaping time to prevent anything from crossing that ultimate limit. And then there is an even deeper problem. If something could go faster than light, the order of events could break. Cause and effect could reverse. An effect could appear before its cause. This is not just strange. It destroys the logic that holds reality together. The universe does not allow that to happen. It enforces the speed limit with absolute precision. Not as a restriction, but as a safeguard, a way to keep reality consistent. Most people think the challenge of crossing the galaxy is distance. And that is true, but only on the surface. The real barrier is much more fundamental. It lies in the way space, time, and energy are connected. Even the idea of distance changes when speed increases. Space itself can stretch and contract. Time can slow down or speed up depending on motion. These are not separate things. They are parts of a single fabric. And that fabric sets the ultimate rules. There are theories that try to escape this limit. Concepts like bending space or creating shortcuts through the universe. These ideas sound powerful, almost magical, but they come with extreme conditions. They require forms of energy that may not even exist in usable form. And so far, there is no proof that any of them can work in reality. So the question becomes even more fascinating. If the universe allows so much complexity, why does it enforce such a strict limit on speed? Why is there a maximum at all? The answer is not simple. It is not just about motion. It is about how reality is constructed at the deepest level. It involves the nature of time, the structure of space, and the behavior of energy under extreme conditions. In this video, you will uncover why faster than light travel is not just difficult, but fundamentally impossible. You will see how the laws of physics build this limit step by step. You will understand what really happens as something approaches the speed of light, and you will discover the hidden reason why breaking this limit would break reality itself. By the end, the idea of crossing the galaxy will look very different, not just far away, but bound by rules that cannot be ignored. Welcome to the channel. Subscribe now and stay with us as we uncover the limits of the universe. There is a number that quietly controls the entire universe. It does not change. It does not bend. It stands as an absolute limit. That number is the speed of light. Light travels at about 300,000 kilometers every second. In 1 second, it can circle the Earth more than 7 times. This speed feels almost infinite on human scales, but in the universe, it is the ultimate boundary. Nothing with mass can reach it. Nothing can go beyond it. This is not just about light itself. That is the part most people misunderstand. The speed of light is not special because of light. It is special because it is built into the structure of reality. It is the maximum speed at which anything can move. Through space and time, even more surprising, this limit applies to everything. It applies to particles, it applies to energy, it even applies to information. No signal, no message, no cause can travel faster than this speed. It is the universe setting a hard rule on how fast anything can influence anything else. Scientists discover this limit through careful observation. No matter how much energy is given to a particle, it never crosses that boundary. It only gets closer and closer, as if something invisible is holding it back. And here's where things start to feel strange. As an object begins to move faster, the universe does not stay the same around it. Space and time begin to behave differently. These changes are not small, they are dramatic. They are measurable and they grow stronger as speed increases. Time begins to slow down for the moving object, not in a poetic sense, in a real physical way. A clock moving at high speed will tick slower than a clock at rest. This effect has been tested with atomic clocks on fast airplanes. The difference is tiny, but it is real and precise. At the same time, lengths begin to shrink. An object moving close to the speed of light will appear shorter in the direction of motion. This is not an illusion, it is how space itself adjusts. These effects are part of a deeper truth. Space and time are not fixed, they are flexible, they respond to motion, and they work together to enforce the speed limit. There is another detail that is often overlooked. As something moves faster, it becomes harder to accelerate it further. Each increase in speed demands more energy than the last. This increase is not linear. It rises sharply. Near the speed of light, the required energy grows so large that it approaches infinity. This means that reaching the speed of light is not just difficult, it becomes impossible in a fundamental way. Particle. Inside powerful machines called accelerators are pushed to extreme speeds. They come very close to the speed of light, but they never reach it. No matter how much energy is added, they remain just below that limit. This behavior reveals something profound. The speed of light is not just a number, it is a boundary that shapes how the universe works. It defines how fast change can happen. It defines how cause leads to effect. And as objects move closer to this boundary, reality itself begins to stretch, slow, and transform in ways that defy everyday experience. At low speeds, motion feels simple. Push something harder and it moves faster. Add more force and the speed keeps rising. This works in everyday life. It works with cars, planes, and even rockets. But as speed climbs higher, the rules begin to change. The closer something gets to the speed of light, the more resistance it faces, not from air, not from friction, from the structure of reality itself. Each increase in speed demands more energy than the last. At first, the increase is small, then it grows again faster than before. The curve is not gentle, it rises sharply, almost like a wall. Scientists have tested this using powerful particle accelerators. Tiny particles are pushed to extreme speeds using enormous amounts of energy. These machines are some of the most advanced ever built. They can push particles to more than 99.99% of the speed of light. That sounds like the limit is within reach, but it is not. Each tiny step closer to light speed requires a massive jump in energy. To go from 909 to 999% takes far more energy than going from 0 to 99%, takes far more energy than going from 0 to 909%. And the closer the particle gets, the worse it becomes. There is a hidden reason behind this. As an object moves faster, its behavior changes in a fundamental way. It becomes harder to accelerate in older 5A. It becomes harder to accelerate in older phi. 6 mass was treated as constant, but at very high speeds, objects begin to act as if their mass is increasing. This does not mean the object gains new material, it means it resists motion more strongly. Pushing it becomes harder and harder. It is as if the object is becoming heavier in motion. This effect is not just theoretical, it is observed directly in experiments. Particles behave exactly as predicted. They resist acceleration more and more as their speed increases. As the speed approaches that ultimate limit, something extreme happens. The energy required to continue accelerating does not just become large. It becomes infinite. This is not a figure of speech. It is a real prediction from the equations that describe space and time. Infinite energy means an endless supply. It means no amount of fuel, no matter how advanced, would ever be enough. This is where the dream breaks, not because engines are weak, not because technology is limited, but because the universe itself refuses to allow it. Even if a civilization had access to all the energy of a star, it would not be enough to push a massive object to the speed of light. Even if every resource in a galaxy were used, the limit would still stand. There is another detail that makes this even more striking. Light itself does not face this problem. It always moves at this maximum speed. It does not need energy to reach it. It exists at that speed by nature. This is because light has no mass. Anything with mass is trapped below this boundary. The moment an object has mass, no matter how small, it is bound by this rule. It can get close. It can get extremely close, but it can never reach or cross that final line. This reveals something deeper. The speed of light is not just fast, it is a dividing line between two kinds of existence, one where motion is possible but limited, and one where that limit defines everything that follows. Speed does not only change motion, it changes time itself. As something moves faster, time for that object begins to slow down. This is not a theory that exists only on paper. It has been tested with extreme precision. Atomic clocks placed on fast aircraft tick slightly slower than identical clocks on the ground. Satellites in orbit experience time at a different rate than people on Earth. These differences are small, but they are real and measurable. As speed increases further, the effect becomes stronger, much stronger. Near the speed of light, time begins to stretch in a dramatic way. For the moving object, seconds pass normally, nothing feels different. But for an outside observer, those same seconds expand. Minutes become hours. Hours become years. At speeds extremely close to light, time for the traveler almost stops when viewed from the outside. A journey that feels short for the traveler could last thousands or even millions of years. For the rest of the universe, this creates a strange split in reality. Two observers, two clocks, two completely different experiences of time. There is a real example that scientists often discuss. It is known as the twin paradox. One twin stays on Earth, the other travels at very high speed through space and then returns. The traveling twin ages much less. Years pass on Earth, but only a short time passes for the one who moved at high speed. This is not science fiction. It follows directly from the equations that describe space and time. Time is not absolute. It depends on motion. At first, this idea feels impossible. Time is supposed to be constant. It should flow the same for everyone. But the universe does not follow that intuition. It links time directly to speed. The faster something moves, the slower its time flows compared to everything else. Now consider what this means for crossing the galaxy. First, from the point of view of someone on Earth, the journey would take tens of thousands of years, even at speeds very close to light. That is because the distance remains vast. The galaxy does not shrink for outside observers. The clock on Earth keeps ticking normally. But for the traveler, something very different happens. Time slows down so much that the journey could feel far shorter. Years could feel like days. The entire crossing might pass within a single lifetime from their perspective. This creates a powerful illusion. It feels as if faster than light travel has been achieved. The traveler experiences a short trip, but the universe does not agree. From the outside, the journey still obeys the speed limit. There is no shortcut here. Only a shift in how time is experienced. There is another hidden detail that makes this even more complex. As time slows down for the traveler, distances in the direction of motion also shrink. Space itself contracts. This effect works together with time dilation. It makes the journey feel even shorter from the inside. But these effects do not break the rules. They preserve them. No matter how extreme the motion becomes, no signal or object crosses the speed of light when measured from any valid frame of reference. The universe adjusts space and time to ensure that this limit is never violated. This reveals something profound. Speed and time are not separate ideas. They are deeply connected. Changing one changes the other, and as motion approaches the ultimate limit, time itself begins to bend in order to protect that boundary. The true barrier is not only speed, it is distance, and the scale of that distance is far beyond normal understanding. The Milky Way galaxy is enormous. It stretches across about 100,000 light years from one side to the other. That number is easy to say, but it hides something extreme. A single HT year is the distance light travels in 1 year. That is nearly 10 trillion kilometers. Multiply that by 100,000, and the result becomes almost impossible to grasp. Even light moving at the fastest speed allowed in the universe needs more than 100,000 years to cross this galaxy. That is the best case. That is the absolute limit. Now consider anything slower than light. The fastest spacecraft ever built by humans moves at a tiny fraction of light speed. At that rate, crossing the galaxy would take tens of millions of years, not thousands, not even hundreds of thousands. Millions. There is a lesser known detail that makes this even more striking. Our solar system is not near the center of the galaxy. It sits far out in one of the spiral arms. That means a journey across the galaxy is not just long. It starts from a position that adds even more distance depending on the direction. And the galaxy is not empty. It contains hundreds of billions of stars. Each star is separated by vast distances. Even traveling between nearby stars takes years at the speed of light. The nearest star system, Proxima Centauri, is over 4 light years away. That is the closest neighbor. Most stars are much farther apart. This scale breaks normal intuition. On Earth, distance feels manageable across continents, across oceans, but in the galaxy, even the closest points are separated by distances that make human travel almost meaningless. There is another layer to this problem. Human lifetimes are short. Even with future advances in medicine, lifetimes would remain tiny compared to galactic scales. A journey that takes thousands of years does not fit within a single life. It stretches across generations, civilizations, and entire eras of history. Some have proposed generation ships, massive vessels where many generations live and die during the journey. The Dest. Ination is reached by descendants who never saw the place they left. This idea solves part of the time problem, but not the scale. The journey still remains vast and uncertain. Even time dilation, which slows time for fast travelers, does not solve everything. From the outside perspective, the journey still takes tens of thousands of years. Entire civilizations could rise and fall before the traveler arrives. There is also the problem of navigation and survival. Over such long time, stars move.
The galaxy itself rotates. Paths change slowly but steadily. A destination chosen at the start may not be in the same position by the time the journey ends. All of this reveals a harsh truth. The galaxy is not just large, it is overwhelmingly large.
The distances are so extreme that even the fastest possible speed struggles against them, and anything slower falls behind in a way that turns travel into a time scale that no human experience can match. This is where the idea of crossing the galaxy begins to collapse, not because of a single obstacle, but because of the combined weight of speed, time, and distance pushing against every attempt to overcome them. The problem with going faster than light is not just speed, it is something far more dangerous. It begins to break the order of reality itself. In the universe, events follow a clear structure. A cause happens first, then an effect follows. This order is not optional. It is the foundation of everything. Every action, every signal, every change depends on this sequence. The speed of light protects that order. Nothing can carry information faster than this limit. That means no message, no force, no event can move ahead of its cause. The universe stays consistent because this rule is never broken. But the moment something moves faster than light, this structure starts to collapse. At extremely high speeds, time does not behave the same for all observers. Two people moving differently can disagree on the order of events. One might see event A happen before event B. Another might see the reverse. This is already strange, but still safe as long as nothing crosses the speed of light. The moment faster than light travel enters the picture, this disagreement becomes dangerous. A signal sent faster than light could arrive before it was sent. From the perspective of some observers, this is not a trick. It is a direct result of how space and time are connected. The equations allow it if the speed limit is broken. This creates a paradox. An effect could appear before its cause. A message could be received before it exists. A decision could be influenced by information that has not yet been created. There is a well-known thought experiment that shows how extreme this becomes. A faster-than-light signal is sent from one point to another. Then a return signal is sent back, also faster than light. Under the rules of relativity, it is possible for the return signal to arrive before the original signal was even sent. This forms a closed loop in time. Information travels in a circle. Cause and effect lose their meaning. The chain of events no longer has a clear beginning. This is not just confusing, it destroys logic. If an effect can happen before its cause, then the cause might never happen at all. A message could prevent itself from being sent. A future event could erase its own origin. The universe would become unstable in a fundamental way. Physics does not allow this to happen. The speed of light acts as a barrier that protects causality. It ensures that cause always comes before effect in every valid frame of reference. It keeps the timeline consistent. There is a deeper principle at work here. The laws of physics are built to prevent contradictions. They do not just describe reality, they enforce its consistency. Every experiment, every observation supports this structure. No signal has ever been observed to travel faster than light. No violation of cause and effect has ever been confirmed. Even theories that explore extreme conditions, such as quantum mechanics or curved space-time, still respect this boundary when it comes to usable information. This suggests something profound. The speed limit is not an accident. It is a safeguard. It keeps the universe stable. It keeps events in order. It prevents reality from folding into contradiction. And this is why breaking the speed of light is not just difficult. It threatens the very logic that allows the universe to exist in a coherent way. Even with all of these limits, the human mind keeps searching for a way around them. If nothing can move faster than light through space, then the question changes. Maybe the solution is not to move through space at all. This is where some of the strangest ideas in physics begin to appear. One of them is the concept of a wormhole, a tunnel through space and time. Instead of traveling across the galaxy, the idea is to connect two distant points directly. Step in at one end and exit at the other, no matter how far apart they are. On paper, the equations of general relativity allow such structures. Space can bend, it can curve. Under extreme conditions, it could fold in on itself. Two distant regions could touch, forming a shortcut. This sounds powerful, almost like a hidden passage inside the universe. But there is a problem. Wormholes are not stable under normal conditions. They would collapse almost instantly. To keep them open, they would require something very unusual. A form of matter with negative energy. Negative energy is not something that exists in everyday experience. It is not something that can be easily created or stored, some tiny effects in quantum physics hint at its existence, but only in extremely small amounts. Nowhere near what would be needed to hold a wormhole open. Another idea is the warp drive. Instead of moving a ship through space, space itself is moved. The region in front of the ship contracts, the region behind it expands. The ship sits inside a bubble of normal space while the bubble travels faster than light relative to the outside. In this model, the ship itself never breaks the speed limit locally. It does not move faster than light through space. Instead, space carries it. This idea also comes from real equations. It is not pure fantasy. But again, the requirements are extreme. The energy needed to create such a warp bubble is enormous. Early calculations suggested it would require more energy than exists in entire stars. Later models reduced this number, but it still remains far beyond anything practical. There is also a hidden instability. Small disturbances could cause the bubble to collapse or behave unpredictably. And there are concerns that such a system could generate intense radiation that would destroy anything inside or nearby. There are even deeper issues. Some versions of warp travel could still lead to the same causality problems as faster than light motion. The universe seems to resist any attempt to bypass its core rules. No experiment has ever confirmed the existence of a usable wormhole. No warp drive has ever been built or observed. These ideas remain mathematical possibilities, not physical realities. There are ongoing studies. Scientists continue to explore the edges of these theories. Small breakthroughs appear from time to time, but none have crossed the line from theory into real-world application. This leaves these concepts in a strange position. They are not impossible according to every equation, but they are not achievable with any known method or material. They sit at T. Key boundary between known physics and speculation. A place where the rules begin to blur but never fully break. And even here, the same pattern appears. Every path that tries to escape the speed limit runs into deeper and deeper barriers, as if the universe is quietly closing every door that leads beyond it. Crossing the galaxy faster than light is not just difficult, it is not just far beyond current technology. It is something deeper, it is fundamentally impossible. Every path leads back to the same truth. The limit is not built by machines. It is built into space, time, and energy themselves. It shapes how motion works. It shapes how time flows. It protects the order of cause and effect. The universe does not simply set a speed limit, it enforces it in every possible way. Energy rises without bound. Time begins to slow, space begins to shift, and if anything tries to go beyond, reality itself starts to break. What feels like a barrier is actually a safeguard. Without this limit, cause and effect could collapse. Events could lose their order. The universe would no longer make sense. The rules that allow stars to form, galaxies to exist, and life to emerge would fall apart. So the speed of light is not just a number. It is a boundary that keeps everything stable, it keeps the universe consistent, it holds reality together, and that leads to a deeper mystery. Why does the universe have this limit at all? Why this number? Why this structure? Why a reality where time bends space contracts and energy becomes infinite just to protect this one rule? These questions go beyond motion. They reach into the foundation of existence itself. The more we try to break the limit, the more we discover that it is not meant to be broken. If this changed the way you see the universe, take a moment to like the video. And subscribe to the channel for more deep explorations into the laws that shape reality. Because sometimes the most powerful discoveries are not about what we can do, but about what the universe will never allow.